Good afternoon friends. In today's lecture we will talk about what is control system. What are the different types? What are the real applications of control system? So let's see. These are the textbook you can refer for this subject. The best standard textbook Nagraj, Gopal, Ugata. You can use some other authors, Williamson's. Alright. So these are the textbooks, okay, available at the stores also. And these are some reference books, Gopal, Richard. Okay, so for feedback we have Franklin. So these are the textbook you can refer for this subject. Then what is the course outcome? So the very first chapter itself, a control system, student will be able to understand the basic concept of control system, as I said, and identify control systems in real life applications. So that is the first chapter's outcome. So what are the real-time applications? Then based on the different modules or the chapters we have the outcomes, and this is prerequisite. So for a students or for a learner who is going to understand the concept of control system, so in mathematics we have learned Laplace transform. So we have the different functions, so depending upon the functions we have the Laplace transform of those functions. Alright, so you have to remember these formulas. Now the question comes, what is control system? So control system basically controlling the operation of another system that can regulate itself and another system. Control system is a device or set of devices to manage, command, direct or regulate the behavior of the device. So basically this is the block diagram of control system, where we have a reference input, okay, then the reference input is applied at the error controller, okay, then we apply different types of controller. So as in the previous lectures we have already discussed what are the different types of controller we have. So most widely used controller is nothing but a PID controller. So at this stage we use different types of controller, PID controller. Then we have actuators also, okay. So at the output of controller we get the controlled signal. The question again comes, what is the need of controller? So that we have already discussed. Then after actuating we get the manipulated value, then we apply some disturbance, that is error, okay, and then it is processed and we get the actual output. But in controlling we get the actuated output, okay, that can be again sent back to the input. So what is the reason why we are sending that signal to back to the input using a feedback signal? That is, if there is some error, if the manipulated value is not closeness to the true value, then there will be a error, maximum error. So to reduce that error we can send that signal again back to the feedback through a sensor. So this is the error detector, where the reference input and the feedback signal again gets combined, and then controller will control that signal again. Means what? It can change the values. Alright, so this is what basically the role of a controller, and this is the entire block diagram of control system. Now what is mechatronics? So as we all know that mechatronics is nothing but combination of all hardware and the softwares, where we require to do the programming also through. So the very first block you can see here, it is called as a physical system modeling. So the very first step is nothing but signal and systems. Okay, what are the different types of signal and systems we have? Then we applied it to the computers and logic systems. So using a software or using some data acquisition system we can acquire the data. Then through our sensors or actuators we can actuate the data, and we can sense the data and again send to the system, physical modeling system, and this cycle will continue. So this is just nothing but a flow chart or flow diagram of a mechatronics. Okay, now again in control system we have different parameters, so you have to understand those parameters. So first is, what is system? So system is nothing but interconnection of elements or devices, okay. Then what is control system? An interconnection of components forming a system configuration that will provide a desired response. So as I told you that manipulated value and the actual value, there will be a difference. That difference is nothing but a error. So control system will try to manipulate those value to get the closeness to the true value, so that there will be less error. Okay, that is what the role of a control system. Then at the last block we have seen the process block. So that is nothing but a planned or under control system. The input and the output relationship between the cause effect relationship of the process. So this is the simple terminologies. Then we have the control variable and the manipulated value. So control variable is nothing but the measured and controlled value which is to be control, and manipulated value, it is the quantity of the condition that varied by the controller. Okay, then we have the control means measuring the value of control variable. So once the control variable is achieved, that can be measured of the system by applying the manipulated variable to the system. So these are the terminologies. You just remember these terminologies because this will help you out to understand the concept of control system, how one parameter or quantity can be controlled. Then as I told you that input set point, this is output which is a control variable, and once we apply the controller, so we get the manipulated out variable and we apply the process, and to do that we apply some disturbances. So if a disturbance is generated within the system, it is called as the internal disturbance. If it is generated outside the system, that will be called as the external disturbance. So two types of disturbance, within a system or outside the system, and that is called as the internal and external disturbances. Now the next topic is types of control system. So depending upon natural and man-made. So in the natural we have universe and human body. So in human body we have a lot of examples where day-to-day life, every part of the body do the functioning, it has its own function, so it should be controlled, otherwise there will be a certain problems can occur in the body if those parts of the body will not functions properly. Then we have the man-made control system, where man-made the example is vehicle and aeroplane, because direction, speed, okay, that is very important to control that direction and the speed. Okay, if you won't control the direction and the speed, then there will be a chances of occurring a accident. So that is a man-made control, and human body is the best example to understand what is natural control system. So here the example is given when manual control system. So in manual control system, the best example is room temperature, water level controller. So as you can see in this figure, the man is standing next to the valve, that is nothing but a control valve. So you can see from the input tab, the water is flowing into the water tank. So the person who is standing here, he is looking to the indicator, water level indicator. Once the water level indicator reaches to its peak value, it will turn off the control valve by changing the position. Okay, so once the water tank gets full, it will close that, so that the input will not be the input flow will be get closed. Then after some time it will again open that valve, so that from the outlet port the water will go to the respective use. Then again, if the water gets empty, it will again turn on the valve and the water will start flowing into the tank. So this is nothing but a man-made control, where water level is controlling through the observation. Now the next is automatic control system, where we have the room temperature regulation via air condition. So in air conditions, depending upon, it sets the two values. Minimal value is the maximum value. So it will set the two parameters of the temperature. One is the minimal and another is the maximum. So if it is reaches to the maximum temperature, so again it will set that temperature to the below, and if it is set to the minimum value, let's say for example 12 degrees Celsius, if the temperature goes, if room temperature goes below the 12 degrees Celsius, so it will again start increasing the temperature. So this is the automatic control system. Then we have open loop and closed loop types of control system. So we have two types. Open loop, so in open loop there is no chance of a feedback signal, because everybody knows what is the meaning of open loop. In open loop we don't have a feedback signal, so that once the controller has obtained the desired response, that cannot be altered or modified. Okay, that is what the example of a open loop system. So in a day-to-day life we use the washing machine, toaster, electric fan, but these systems also can be used in the feedback form, because nowadays the technology has enhanced. That's why the same examples can be used for the closed loop system, but there we have applied the feedback signal. Here is the example of open loop system where there is no feedback. Okay, so you know the advantage of open loop system, which is simple, easy to maintain, stable, convenient to use, output difficult to measure. So these are the advantages. Now the drawback is inaccurate. Obviously it will be inaccurate because there is no feedback, so there is no modification can be occur. If there is a error occur at the output, then cannot be rectified. That is why it is inaccurate and unreliable. Any change in the output cannot be corrected automatically. So that is the drawback of open loop systems. That is why to overcome this we use the closed loop system, where there is a feedback. So once there is an error, so it can be sent back to the input again, and that can be changed through a control system by applying a controller. Alright, so the next is closed loop, where you can see here the measurement. That is nothing but output is connected to the input again through a measurement, that is a sensor. So the best example to understand is nothing but a refrigerator. Refrigerator is an example of closed loop system, where it will again the same example as I given for the room temperature. Refrigerator does the same. Alright, iron does the same. That is a closed loop system. Alright, advantage: control system are more accurate. Closed loop systems are more accurate even in the presence of non-linearities. Closed loop systems are less affected by noise. Okay, and it is more stable. But the drawback is are costlier, because it requires to again rectify the signals, oscillatory response, feedback reduces the overall gain of the system. This is the major drawback of a closed loop system. Our gains of the system gets reduced, and stability is the major problem in the closed loop system, and therefore we required a more controlling way to control the stability. Now the difference between the open loop and the closed loop: the system whose control action is free from the output. That means there is no feedback signal. Okay, and if there is a control action can be occurred, that is a feedback signal, because of the feedback signal. Then components: controller and controlled process. Here we can apply the amplifier as a feedback signal, measurement as a feedback signal. Construction of open loop, obviously the simple one, whereas the closed loop is a complex one. So this is the difference. You can just go through it, it's very simple. Alright, there are a lot of points are given. You can see the examples: traffic light control, and there in the feedback we have the speed and the pressure control. Okay, so these are the examples. In a day-to-day life we use these systems. Now that again feedback we have already studied. Now feedback can be positive or negative, as we all know what is positive feedback and what is negative feedback. Alright, now the next type is a servo system. So the servo system is a feedback control system in which the output is some mechanical position, velocity or acceleration. So here the examples are given. That is antenna positioning system, which is a feedback signal. Once the control panel is controlled through a controller, we get the position of the antenna because of the deflection in the positioning sensor, and because of the motor, so there will be a deflection in the antenna. But if that deflection is not proper, then again it's sent back to the input, that is through this line. So this is a feedback signal which is called as a servo mechanism. Now we have different types. We know what is linear, non-linear control system, right? So here are the example of linear and non-linear system. Then we have, this is the non-linear characteristics. Then we have, this is the adhesive characteristics. Alright, then we have continuous data, discrete data. So you know what is discrete data and which is continuous data. Continuous signal, which is continuous in nature. Discrete, where we have the signals which is divided into time intervals. Okay, so that becomes a discrete signal, where we this is nothing but a discrete in nature, where analog signal is can be converted into digital one through this technique. Alright, then we have human system. Pancreas, we know what is pancreas. It regulates our blood glucose level, because pancreas generates an hormone. That hormones is nothing but a glucose. So pancreas, if the pancreas is not if it stops generating the hormone level, then there will be a problem in the glucose level, and because of which the diabetes can be occur in the body. The diabetes patients, what is the meaning of diabetes? That is nothing but in the parts of the human body, the glucose building of glucose gets stopped because of the pancreas are not working properly. Then we have adrenal gland. So these are the gland of the body, automatically generated to increase the heart rate and oxygen's time of flight. So the adrenal gland generates the some type of hormone, because of which our this heartbeat and the blood pressure remains the constant or stable. If there is a changes in this parts of the body, that is gland, then there will be a changes in the heartbeat and the uh, blood pressure. So this is something connected to the adrenal gland. So this is nothing but the example of automatic control system, where in day-to-day life it's a natural system where we cannot do anything to control these parameters. Then we have the eye. Okay, follow moving object, hand, that is again example, temperature, as I told you. So these are the examples of a natural control system. Then again example of a room temperature, where we have the desired temperature. Okay, so the heater or air condition is used. So heater and air condition will be used depending upon the minimal and the maximum temperature range. If it is goes below the minimal one, the heater will turn on. If it is go above the maximum temperature, then the air condition will be on. And based on this is nothing but a controller, and this is what a heat loss gain from outside. So this is the outside noise. Okay, external noise is applied to the system. And this is a house, this is nothing but a room, where the temperature of the room is controlling, and through a sensor, this is nothing but a thermocouple thermometer RTD, can be placed in place of the feedback signal, so that it can measure the value, and if it is not desired to the control variable value, then again send back to the signal, and using a controller we can set that value to the nearer to the accurate value, so that there will be less error in the output. Alright, so this is an example of a room temperature. Then as I told you that we have the different parts of the body: pancreas, stomach, tissue, liver. Okay, so every parts of the body has generates and hormones, and because of that hormones our system work properly. If one of the parts of the body like pancreas, liver does not work properly, then there will be a problem, and because of that everything is interconnected, so the system of the body will not be linear, that will not be stable, so there will be a problem. So we have to control that, but this is not a man-made, this is a natural. So in man-made we have given the example of a car. While a person driving a car, so he has to take care of the speed and the direction. So these are the two parameters which is very important in man-made controls type of control system. Then we have feedback and feed forward. So everybody knows what is the advantage of feedback. Let's see what is feed forward control system. Using feed forward control, the performance of control system can be enhanced. Process variables such as pressure, level, flow are interrelated, and so one variable may affect another as disturbance in the process. Feed forward system measure important disturbance variables and take corrective action before they upset the process. So here feed forward. The advantage of feed forward is takes corrective action before the process is upset. So here the advantage of feed forward is what, once the output is we get the output, so if there is a difference in the value, then there will be a maximum error, then again has to send back, that is a feedback signal. But in feed forward signal, at that initial point only we measure the value. If there is an error, then at that stage only we rectify that signal. So that is the main advantage of feed forward. Theoretically capable of perfect control, does not affect the system stability. That is the advantage of feed forward system. Okay, then disadvantages: disturbance must be measured, require more knowledge of process to be controlled, because we are initially trying to rectify the signal. That is why we require more knowledge. Ideal controllers that result in perfect control. So these are the drawbacks. Okay, but the advantage is more. So comparatively we use the feed forward signal compared to the feedback signal. Okay, so this is all about control system types. Okay, real-time applications. So we have taken a lot of examples. If you have any doubts, any queries, so the link is provided on the YouTube, the contact number is given, you can contact me. Okay, you can WhatsApp me your doubts. All right, all the best, thank you.